expressions. And really, this is going to touch base and connect with what we were working on with different properties and different ways to set it up using a property to create equivalent expressions, and really looking also at the idea of the distributed property and how that works, and how we can use that to create equivalent expressions. So first things first, let's add some more terms to our vocabulary when it comes to math. The first thing we got to talk about is what a term is. A term, not just an idea of like what a vocabulary is, but is the idea of any number or variable that's referred to as a term. So if I have a number like 3x plus 7, they have two terms, okay, because there's two different numbers or variable sets. Then we have a coefficient. In this case, our 3 is our coefficient. This is our coefficient right here. We have a constant term, and that's any number without a variable or a term without a variable. So it's this right here. It's our 7. And it actually includes the positive, the plus sign. And then finally, like terms, numbers have the same variables or exponents are exactly the same. Here, neither one of these are like terms. But if I was to add a 2x and 3x would be considered like terms. So we're going to take a look at how do we simplify expressions that have like terms and unlike terms together. So for example, if I take a look at this one, if I want to simplify this expression, we know that parentheses between two numbers is multiplication, but 6x is a term and 4 is a term. Now, 6x and 4 aren't like terms, but numbers are like terms. And multiplication doesn't have to have like terms to work. Okay? Think about multiplying fractions. Fractions are really a great way to understand like terms and how this works. And if I can multiply two numbers, whether they have like terms or not, in fractions, I can do the same thing here. So I can put together 4 times 6 and get 24x. Okay? And I can do the same thing down here. If you put together 7 and 3, what would you get? 21y. Let's take this up a notch and take a look at what it might look like with a little more challenging problem. So now we have 3 friends that pay X dollars for admission to the museum plus $1 to go to a mummy exhibit in addition. A 4th friend that will pay for the admission but doesn't want to go see the mummies. So write and simplify an expression that represents the total cost. So we want to think about each sentence as its own little expression. So 3 friends, X plus 1. So what does each friend pay? We ask ourselves, well, each friend pays their museum admission plus their $1. How many friends did it? Well, 3 different friends paid that exam amount. Our next expression is a 4th friend, so one more, paid admission. Well, admission was X, so they're going to add X. Now I write and I want to simplify this. Well, I've written the expression. Let's check. How can I simplify? Well, I can distribute my 2. I can multiply every time and any time, whether they're like terms or not. I'm going to multiply with a number that's sitting in front. Well, and there's always a 1 in front of that X. So 3 times 1 is X. 3 times 1 again is 3 plus X. Now I can put together my 2 like terms and get 4X plus 3 is the correct answer for how many, for the expression for the total cost of the museum. Okay. All right. Moving on to the next one. So this time it's your turn to try this one. Go ahead and pause the video and see if you can come up with the expression and then simplify it. All right. So same setup. So we have 4 friends going to a baseball game. It costs them each X dollars to get into the game. And 3 friends buy a hot dog too. So 3 friends are going to pay X plus 2. 1 friend didn't want a hot dog. Maybe he doesn't like hot dogs. There's our expression. That's one way I could write it. Okay, so I'm going to go ahead and distribute my 3. So I get 3x plus 6 plus x. Again, we have our like terms. We get 4x plus 6. That's the total cost for admission for those 4 friends. All right, now we can do the same thing when we look at just numbers without word problems. I say, okay, well, I've got a group with the associated property, but I can change my grouping and make it work. I can also move my numbers around because it's all addition. I can put together my 14y and my 22y. To get 36y plus x. What would I do to move this around and solve to simplify this expression one more step? You're right. I would put my 7 and 15x to get together to get 22x plus y. All right. Let's take a look at another style. Let's talk about using the distributed property when I can't combine. X and y don't have the same variables, so they cannot be combined, but I can multiply. And that is one step farther of distributing, is simplifying the expression, is removing one of the operations. So it becomes 8x plus 4y. There's nothing else I can do here. I can do the same thing here. Go ahead and do the same thing here and see what you come up with when you distribute that 9. 9x plus 27y. All right. Moving on to another style. What about the opposite? One thing I do is I distribute. I can take that term and give it to both. And I get 3x plus 9. Well, I can also remove that same number out, and that's a term called factoring. So distribute is one side of the coin, factor is the other side. So I'm looking for the greatest common factor. What is the GCF of 27 and 18? Well, I'm going to factor that out. I want it to finally look something like this. So I'm going to say, okay, well, I can divide both sides by 9. So I'm going to say that's my number I'm going to factor out. What do I get when I divide 27 by 9? I get 3x. And 18y, I get 2y. So I have, in essence, I'm going reverse from our distributed property back to where I started here, from where I simplified it back out one step. And that comes in handy when if I do get numbers, I can solve them much easier. Go ahead and see what the GCF of 16 and 8 are and factor this problem. So you divide it both by 8, so you're going to end up with 2x. And be careful, you don't want to put a 1 here. If you already have y, you don't want to put a 1y because that's an extra number you don't need. It's not as simple as you can make it. All right, and I can do the same thing here. I can work my way with distributed property again. Word problem on that. Each basket has 3 apples and 1 pear. So A stands for the cost of apples, P stands for the cost of pears. So I'd have 3A plus 1P is the cost of 1 basket. What if I want 5 baskets? Well, I want 5. So what am I going to have to spend if I'm going to distribute to be 15? I'm going to cost whatever it costs for 15 apples plus 5 pears to make all 5 baskets for the fruit basket. All right, your turn to give this a try with our tennis ball problem. All right, so you set it up with 6 cans, 2 yellow balls, plus 1 yellow ball. Then you distribute to get 12y plus 6x. Tells you exactly how many of each color are in 6 cans of tennis balls. All right, and your last thing would be to simplify this. Now, here's the trick on this one. There's always a 1 there. So it becomes 12y. All right, if you have any questions, feel free to reach out. I'd be happy to help.